in this presentation, I want to open your mind. So, what does this mean? Karunakara said that you are not doing measurements very much outside of this building. Is it so? You are not very much doing measurements in the field. Is it so?
Direct measurements we do not do. We bring the samples from the field and we do them.
Yes, samples.
Although we have a survey meter, the sodium iodide survey meter, I can show you later. We don't rely on it much.
Yeah.
Because anyways, reasons are twofold. One is we don't have any kind of anthropogenic activity in India as of now. So it doesn't make any sense to do a survey.
Now I will tell you what we are doing in our institution regarding field measurements, which are quite challenging in some cases. Look at this one. After introduction, I will ask you, what is a laboratory? Is it a stupid question or not? Let's see. Then I will go. Sorry?
The conditions are controlled.
Yeah, it's very difficult to do measurements outside. I mean, reliable measurements. You cannot carry your laboratory system into the field. So, what to do when you have to do field measurements or field sampling? And how to do sampling and sample processing in the field. Alpha spectrometry and gamma spectrometry in the field. Right. Different field measurement techniques. I mean, outside a fixed laboratory like this one. Maybe applied, for example, in the areas of nuclear security, nuclear safeguards, nuclear emergency, or like in this laboratory, environmental studies. So, in case of nuclear security, so there's a need sometimes, definitely not very often, to detect radionuclides that may be dispersed by using a dirty bomb, for example. Just an example. And finding, for example, signatures. If alpha particle emitting radionuclides are used as a poison, you perhaps know the Litvinenko case. Do you know this Litvinenko case? You don't know. Around 10-15 years ago, Finnish government, in fact, 2008. All right. In fact, Russian government killed one of their spies by using polonium-210. The isotopes you measured yesterday in Alpha, but the amount was very big. So this poor guy died. If I remember it correctly, it was inserted in tea or some drink or something.
They have used two techniques. I don't remember. One is on polonium-210 and one is on nerve gas, because salts were based. So the Russians used.
Yeah.
So polonium-210, I think they have injected into a drink, I'm not sure, but or they have put it into the doorknob. So,
yeah. So in nuclear safeguards, they are interested on mainly interested on actinium-like radionuclides. Of course, in a nuclear emergency, if an accident happens in a nuclear power plant, then it is absolutely necessary to do rapid measurements in the field. And also sometimes in environmental studies. Now I really want to open your minds in the measurements. So, you know, radiation measurements in the field pose challenges, for example, sampling. And in the next slide, measurements. But the problem in sampling is harsh environmental conditions. In my mind, sampling should be planned so that sample processing is not necessary if you do the measurement in the field. And simplified means should be developed. And in case of a nuclear accident, there's no time to transport the samples in a fixed laboratory, which is possible locating far away. So, I think you do this way, but I think that this way is not necessarily the best way. It's much better to do measurement there, outside, and send the data that can be analyzed, for example, here. Challenges about the measurements. So, if you bring them out of a fixed laboratory, there are demanding conditions and detectors must be appropriate for field measurements. But if the detectors are already in the field, it is possible that you can get analysis results very quickly. Nowadays, in present days, data transfer is quite easy. But for example, 20 years ago, it was not easy. We have now quite good systems here and in Finland too. So, transfer data, no samples, if possible. So, in that case, we have developed a quite nice system in my organization. We are doing remote expert support in our building. Yankees calls this as reach back. So, all the data that you can see here, they are collected somewhere outside of our building. Alpha spectrometry, gamma spectrometry, dose rate measurements, pictures taken outside. So it's quite challenging task for this guy to analyze things. Problem for the field measurements is that very often it happens, at least in Finland, for example, if police or firemen do measurements, for example, in an industrial area, they don't understand radiation at all. You understand radiation. They don't understand at all. So, what will they do? They have some equipment. I hope this equipment can automatically send the data in our reachback center. Then the guy sitting there can analyze the spectrum, or if the dose rate is high, then he can tell to this guy that, all right, please stay away, now it's a dangerous radiation field close to this area. Once more this one. What kind of analysis techniques can be used outside in a fixed laboratory or sampling techniques? Do you think are these good methods or these? Definitely no, because these equipment are quite heavy, very expensive, very sensitive. They do not stand rain or moisture or these kind of things. So, feasible for measurements in the field. Alpha spectrometry or gamma spectrometry. But how to do gamma spectrometry there? Let's see. So, field measurements can be done using different platforms, for example cars, etc., and different measurement equipment. And the point is now that here, at least from my point of view, is that what does it mean when we talk about laboratory? So, what is a laboratory? This is our normal understanding what is a laboratory. There are chemical things and different kind of analysis equipment. So it's situated in one place. Several sample preparation techniques are possible, and also different analysis methods. The one located here or in my organization. So, this is another option, movable radiometric field laboratory. It is built, for example, in a trailer. But the point here is that usually the measurements itself, they are not possible when the car or trailer is moving, like in this case here. It's a limited set of sample preparation techniques and also limited set of analysis techniques. And for example, Finnish Defence Forces has developed this kind of system. In fact, it contains radiometric laboratory, biological laboratory, chemical laboratory, all these things. What about next? This is our car. We call it a moving laboratory, and we call it Sonni, which means bull in English. Why? Because these tubes here, they are air sampling tubes. We have a strange level of humor again. So, we are capable of doing measurements outside when the car is moving. So, it is of course not so heavily equipped compared with a fixed lab. But it is still capable of doing sampling and relevant measurements. And it's capable to send information to our headquarters. But mobile, you have your mobile phones. This guy has mobile laboratory. Well, the concept of laboratory, it's how to say, it's not very clear. Anyway, the system is located, total system located here. There's a gamma ray spectrometer, multi-channel analyzer. This type of laboratory can be operated even by a single person, like him. So, prerequisite is the possibility to send the measurement data autonomously to a remote location. However, if this guy is valid enough, he understands radiation-related things, then he can analyze the spectra in the field. It's possible. So, point is that there is no heavy instrumentation. Typically, gamma ray spectrometry. But in this case, he is operating now in situ alpha spectrometer system. So this is not a counter. This is a spectrometer. Autonomous labs. We have a sampler close to our institute, looks like this one. Sampling is done here. There's a filter. There is also a deposition equipment there. So this system can automatically collect the data. There are Geiger counters located here. You cannot see it well. There are also lanthanum bromide scintillation detectors, so we can get real-time spectrum from that system. Of course, limited set of measurements. Or there are not many options to do different type of measurements, mainly gamma ray analysis. But there are some other options, like these. These are used, for example, by police if they are checking some dangerous objects. We have implemented, as I earlier told you, a sampler into a small UAV and a spectrometer. This is bigger one. This system includes very big sodium iodide detector. And finally, this remote expert system. So, in this laboratory, neither sample processing nor measurements are possible. So, do you call this as a laboratory? I don't know. I call it as a laboratory because we are doing analysis. So no sample processing, no measurements. The data can come from lab types mentioned in the previous slides, but data can also come from other places. For example, we can use maps, Google Maps. Do you know what is a waterfall picture? Perhaps you don't know. I will explain. This is very important in those cases when the measurements are done in the field and each measurement time, the measurement system is equipped in a car which is moving. And that car wants to see is there any object close to the street that emits radiation. So that waterfall picture is like that. So let's assume that there is a spectrum. Looking like this one. But if the data acquisition time is, for example, 10 seconds, and you get 1,000 spectra, how they do or how they analyze in the reachback center these 1,000 spectra, it's not possible. However, if you visualize those spectra so that they are not looking this side to the spectrum, they are looking this spectrum, this is your eye. You are looking this way, and what you will see, let's delete this one here. They are looking the spectrum so that there is in fact, one channel or one bin, how to say it, time resolution, so that in each time, for example, in this case, the color, I mean the number of counts here is blue, because the number of counts is high. This might be black. This is again blue, again black, etc., etc. In the next 10 seconds, same thing holds. You might get a different spectrum, like this one. Then at the next 10 seconds period, the point is this is a high level part, quite high level part here, low level part, etc. for this black spectrum here. So if you have multiple of these 1 pixel widths, then you can easily see that, okay, now the car is in some other position, and you can see that something is happening, for example, in this point. I don't know what's the point here, maybe perhaps this. So this is so-called waterfall picture. So you look at the spectra like this, not like this, as you are doing now. I hope you understand this. But this is just a way to present spectra according to colors, not according to peaks itself, but the number of counts. Any comment? Do you understand this? Yeah. Let's look at the sampling. What do you think? Is this possible in the field? I mean, you should carry strong axes, for example. No, it's not a good idea. No. However, the point is that if you simplify sample processing in the field, this simplification means fine-tuning So you minimize the sample processing. It is quite often sufficient. Major changes are not needed for the sampling. Typical example is air samples. If you select sampling material properly, for example, if you are analyzing alpha spectrometry in the field, which is possible, it may be better to use membrane filters instead of glass fiber filters. It depends on the case. Filter type is essential thing in alpha spectrometry. Here are some examples for alpha measurements. You can put the filter directly into the vacuum chamber if you need a vacuum chamber, because it is possible to do the measurements without any vacuum. Wipe samples. This is a piece of uranium. I took samples. This can be put to the detector here, to the vacuum chamber. And then some simplified processing system. This can be used, for example, in a car. It's very easy to put there, for example, an infrared lamp. And then you can put this beaker also in this chamber. What do we do in the measurements, in the field measurements and sampling? So we laminate the filters. You know that filters are like this one. So it's when it's raining or difficult conditions, windy conditions, this is very difficult to operate. However, if you laminate the filter so that it's quite stiff, and there is a hole through which the air goes, then it's easy to do sampling in the field. And this filter can be placed as such into a vacuum chamber or into a gamma ray spectrometer. And the use of battery-driven samplers, like this one, no external electricity is needed. So there is no major filter manipulation, only filter cutting, because maybe you can see that in this filter there are 3 holes here, here and here. Why 3? The point here is that this 3-part structure allows the use of complementary and simultaneous analysis techniques. So we can put that part of the filter to the vacuum chamber, that part of the filter to a gamma ray spectrometer, and that part of the filter, if we want to analyze, for example, individual radioactive particles. So we can do 3 different analysis techniques for the same sample, very easily. We just cut the filter in 3 pieces using this kind of system, which is very easy system. We put the filter like that, then do this, take out of the pieces, and substitute them to the measurement system. Another simple cutting procedure, but not so handy as the previous one. So the edges of this iron cylinder It's very sharp so that it can cut a piece of the filter. But this is not handy. About liquid samples. If you take a small sample from sea or lake or river or whatever liquid is, you can take a few milliliter liquid sample using a pipette, for example, put the liquid on a beaker. You can, in some cases, insert small amount of another type of liquid to remove the surface tension. This is possible. Evaporate the liquid so that radionuclides stay there, and put this beaker to the vacuum chamber of an alpha spectrometer. And you can get out quite good spectrum. Wipe samples. For example, here is one of my colleagues doing, in fact, polonium sampling from the walls of our garage. It's an accumulator driven sampler, and there is a nozzle here with a membrane filter. This is another system. You can take samples from soft surfaces. IAEA has developed an impactor here, which does the same thing. You can take the sample like that. This is a volcano picture. Not very relevant in this case, but anyway, it's a good visualization. Let's look at alpha spectrometry in the field. As I told you, several measurement techniques are available for air filters and other samples too in the field. Gamma spectrometry, alpha spectrometry, beta counting, imaging techniques, I mean digital autoradiography, dose rate measurements, etc. In our car, we have in the roof, somewhere here, there is a high-purity germanium detector for nuclide identification. There are two sodium iodine detectors. Here, one in this wall, and in an other side of this car, one detector. Inside the car, there is also a high-purity germanium for sample measurements. And we also have alpha spectrometer here. In this case, there is only one alpha chamber. So I think that high-resolution alpha spectrometry is possible in the field conditions. Not in open sky, but if you install the equipment into a car, it's possible. In this case, there is laminated filter here, inside the vacuum chamber. So, our Sonnicar Bull, so there is a MCA here, alpha spectrometer. This is so-called NIM rack. Power supply is here. And in the back of the car, we have a vacuum pump. Right, this picture again. So radon concentration in the garage air is around 100 becquerels per cubic meter. So is it possible to detect polonium by using non-destructive alpha spectrometry? So polonium is present on the surface, not in the air. So this garage was quite old, so that there is radon in the air. Radon disintegrate into this polonium and disintegrates rapidly into these metals. They are small particles, and these particles are deposited on the surfaces. They do not stay in air. They will deposit on the walls. All right, let's see. It is possible. So, we used a membrane filter, and we found out that it is possible to detect polonium in this level. There are some other nuclides too. And in this case, you can see that the peaks are very sharp, very, very sharp. Suppose that in that wall there might be plutonium isotopes, americium isotopes, a lot of other radionuclides. Then you might have a very good spectrum in one short sampling. So, this is the sampler that we put into this small unmanned aerial vehicle. The size was this. So, this is my very old car. I was a little bit embarrassed when I drive this car because I put them here and tested how this sampling system is working. So we used different type of filters, and I used non-destructive alpha spectrometry. So the filters which are inside here in these two samplers, they are membrane filters which are put into the vacuum chamber. We tested several filter types. For example, these two are glass fiber filters. We can quite easily polonium 214, but using fluoropore membrane filter, it's a quite good filter, I think so. The peaks are very thin. So these measurements are really done in outside air. Let's suppose that there is plutonium, for example, in the air, and you have to do quick analysis. I think it's I think it's a good, not a good system to do sampling like this, but sampling could be like we do in our Sonni vehicle. Does this open your mind at all? I hope so. All right. We have an alpha detector here. So, is it possible to measure quality alpha spectrum in the field conditions, in normal temperature and pressure, and also in the laboratory? Well, it is possible if the sample is thin, but if the sample is thick, we might have some difficulty. But there is another possibility that I investigated around 15 years ago. So let's assume that there is a source, and let's put a honeycomb collimator in front of the alpha detector here. So these are the walls of this honeycomb collimator. What happens? Goes this way, but doesn't go to the detector. So this way, it collides to the wall. This case, it goes to the detector. So what happens? Original spectrum is like this one, with these three isotopes. However, if we collimate, we get a good spectrum. But perhaps you already realize that there are some bad things too. Bad thing is that we lose efficiency. So we do not detect these alphas, we detect only these, which are going quite perpendicularly to the detector. But this is good when we need to identify nuclides. There is a comparison. Energy from 4 to 10 MeV, these are normal nuclides present in air. This spectrum is from a ideal sample. This one, I think it's a fluoroporefilter in this case too, quite thin. Vacuum chamber. If you do not use vacuum chamber, the spectrum looks like this. However, if you use collimation and also NTP conditions, the spectrum looks like this. So it was for me it was a surprise that it is possible to get high resolution alpha spectra in normal air conditioning.
Why there is tailing to the right side and two colony?
This is because of it is mainly because of this nuclide, Bismuth 210. It emits betas, and because this is very short-lived, betas are in coincidence with alphas, and that's why there is right side. I have written a paper 20 years ago. It's explained there. All right. So we have developed a viable equipment which is known as Adonis, this one, for in situ alpha spectrometry from smooth surfaces. So we can measure by using this system. This is the alpha detector itself. We can measure alpha spectra in the field conditions here, here, in this surface, whatever, and we get very good spectra out, very good. So we get rid of NIM electronics. We have battery-driven multi-channel analyzer in the backpack. It's a computer-controlled system, as you can see here, and it is able to send the data to a remote location, to reach back, for example. Very handy system. It can also include gamma or even neutron spectrometers. Well, neutrons are not very often used in the field measurements, but basically. So this guy is really measuring alphas from this surface and able to automatically send the data. And again, this picture. So if this person, for example, is using his car or bike and has a gamma spectrometer with him, so it's possible to send data while biking or driving the car automatically. This is one of the pictures that our reachback center can see in real time, no delay. Okay, some seconds delay, of course, but it's not significant. This is alpha spectrum. This is, in fact, beta spectrum detected by this system. So this system detects also betas. And we can locate, for example, radioactive sources if it is located in some of these places. In fact, we are using this system normally. For example, if Trump, future president of USA, will come to Finland, our team is using all of our systems to check that, okay, roads are safe to go, etc., etc. I don't know every details. We are doing work together with police. Now I show you only a few slides regarding in situ gamma spectrometry. I think when you are using measurements outside, you are using systems like this. So there is a tripod or trolley holding the detector. Distance is 1 meter above the ground. Handheld system, yeah. All right.
But measurement is usually 1 meter.
Yeah. So do you automatically send the data somewhere, or do you collect it only locally?
I have not seen. I don't think so. It has a memory disk.
Yeah.
We can retrieve and send it.
Yeah.
So the system itself would not have a direct data.
Yeah. All right. It's of course a good system like that. So the goal of this system is to determine soil activity concentration. It is usually done by detecting natural nuclides, sometimes detecting cesium, as a function of soil depth. And in case of a nuclear incident or accident, we can detect fallout or deposition. So why I I'm always talking about these accident or incident things. The reason is that in my organizations, we have to be prepared for these kind of things. For example, if Chernobyl-like accident happens, so we have to react very quickly. That's why we have developed all these strange systems. So, in this measurement, we have to take geometry into account 1 meter above ground. Normally we have to assume uniformity of the surface, but form of terrain, vegetation, surface, roughness, trees, etc., must be taken into account in some cases. All right. So, system, if you want to analyze becquerels per surface per square meter, then you have to do some calibration, and it's very important. I do not explain this. You can check these slides later. But the point is that you can start the calibration by using point sources located at different distances from this symmetry axis. So we have used different equipment. This is a military equipment here. For example, after Chernobyl accident, it was possible to detect deposition of cesium. There is a very big scintillation detector and also high purity germanium detector in the helicopter. All right, this is it. Now, my intention was to open your mind to see that there are a lot of different things that can be done in the field measurements. Measurements are quite challenging if the conditions are bad, but it is doable. Thank you very much. Questions? Comments?